Hey there, welcome to WonderfulTutor.com. My name is Adam Reich, and today we're going to be covering the subject of converting fractions into decimals and decimals back into fractions. Yeah, so it's like you always like kind of, all right, cool. We're going to start with the concept of what a fraction is. Everybody has seen fractions a million times. I'll give you an example of a fraction. Let's say the number 1/2. Let's talk really quickly about the different parts of a fraction. The top number in a fraction is called the numerator, and the bottom part is called the denominator. The denominator represents all the possible parts that there are. So for example, if I have just a giant pizza pie and I take that pizza pie and I slice it down the middle, cut it perfectly, I will have two parts. That's what the denominator is. The full number of parts that exist. The numerator is, in this case, for example, how many parts that we've eaten. So if this is a pizza pie and we cut it up into two, and let's say we ate one, I'm coloring it in right now, one out of those two slices. That's just the basics of what a fraction is. What a lot of people don't realize when they look at fractions is that they're actually division problems. In fact, when we look at a fraction, we can see that it's basically one number over another number. Oh, well, look at what that looks like. A division sign. And because it looks like a division sign, guess what? It actually is a division problem moving around wherever you put it. We can actually say that 1/2 is equal to 1 divided by 2. We're going to create a long division symbol, just like we did back in 4th grade. We're used to having the larger number on the inside with these kind of problems and the smaller one on the outside. But in this case, the 1 is going to be on the inside because we always put the numerator inside and we put the denominator on the outside. So let's see if we can remember all the steps of doing long division. The first step is going to be just very basic division itself. The second step is going to be multiplication. The third step is going to be subtraction. And the fourth step, we're going to bring the next number down. After we go through all 4 of those steps, we're just going to repeat all of them again. All right, so let's see if we can try that here with this problem. So 2 goes into 1. Pretty easy. How many times does 2 go into 1? Oh, doesn't fit in a full even one time. So 2 going into 1, it goes in 0 times. Well, what do we do with that? Well, whenever we get a 0 as our first answer, we're going to put a decimal after both of those two numbers. Now, anytime you add a decimal at the end of a number, there are actually an infinite number of zeros that come after it, and we can use as many of them as we want. So in this case, we're actually going to put 1 0 after the decimal, and now it doesn't look like 2 going into 1. Now it actually looks like 2 going into 10. That we know how to get the answer to. 2 goes into 10 5 times. 5 times 2. That's our second step, is multiplication. So 5 times 2 is 10. So we can see here our third step in the division process, the long division process, is subtraction. So we're going to subtract 10 minus 10. We get 0. And we can see here at the top of our division problem is the answer, 0.5. That's right. 1/2 is equal to 0.5 as a decimal. We've actually converted that fraction into a decimal. Now, most people know that 1/2 is equal to 0.5, but a lot of people don't know how to prove that mathematically. Well, that's what we just did. So what I think we should do now is let's try another one. Let's try 5/6. So if we have 5/6, how do we convert that into a decimal? Well, again, we know that 5/6 is a fraction, which means that it is a division problem, or 5 divided by 6. Now, how do we write that? Again, when we create a long division problem, we're going to put the numerator into the inside, and we're going to put the 6 on the outside. All right. Now, again, what are our steps for doing long division? Long division, step 1, do the basic first division. After we get that, we're going to multiply. Our third step is going to be to subtract. Our fourth step is going to be to bring the next number down. And then the fifth step is, well, there's no exact fifth step. We're just going to repeat the whole thing all over again. All right. So let's start with step 1, division. How many times does 6 go into 5? 0 times. Didn't get us very far. But if we remember from the last time that we did this, all we have to do is put a little decimal. After the 5, then another little decimal. After the 0, try to more or less keep everything lined up. It might not make that much of a difference right now, but as the math gets harder, you'll find that lining things up is really going to help you. So now that we have our decimals there, we know that inside the division problem, we're going to put a 0 after that decimal. And so it's no longer 6 going into just 5, but 6 going into 50. How many times does 6 go into 50? One way you can think about it is 6 times what will get us the biggest number that is less than 50. So if I say 6 times 10, that's 60. Well, you can't even do 6 times 10, right? It's got to be a number less than 10. But 6 times 9, if I, that's 54. That's above 50. It's too big. 6 times what? 6 times 8. If we remember our times table, 6 times 8 is 48. We do subtraction. That's our third step. 50 minus 48 is 2. Well, we could stop there, and we know that we have a decimal value that is roughly 0.8. That is 5/6 is approximately equal to 0.8. But maybe we could get a little closer to the right answer by continuing our long division problem. So the way that we can do that is that we can extend this line up here, and we can actually put another 0 here. The last step that we did in our problem was subtraction, and that was step 3. So you can see here, step 4 is actually going to be to bring the next number down. In this case, that's another 0. 6 goes into 20. How many times? If I estimate, well, maybe 5. 6 times 5. Oh, that's 30. That's too big. Let's go down a little bit. 6 times 4. 24, still too big. Let's go down one more. 6 times 3. That's 18. So we'll go ahead and we'll say 6 times 3 is 18. It's less than 20, which is what we want. We subtract, and see if I can squeeze this down here. 20 minus 18, we get a 2. So now we're actually closer to the right answer because we don't just have 0.8, we have 0.83. At the bottom, we have a 2, which means we're not done. We would be completely done with this problem if that were a 0. But because it's a 2, it actually means that we could keep on going. We could keep on bringing down more zeros and dividing and more zeros and dividing. But I think for right now, we're going to stop. We'll just say that 0.83 is close enough. So we know that approximately 5/6, it is approximately equal to 0.83. And by the way, this little symbol right here, those two wavy lines, that means like approximately. So if we put an equal sign, I mean like, that's it, 0.83. But it's not. 5/6 is approximately 0.83. All right. And that is our answer there. We've now converted our fraction into an approximate decimal. Why don't we try now converting a decimal into a fraction? In fact, why don't we take the last decimal that we got, 0.83, and see if we can convert that back into a fraction. Generally speaking, converting fractions into decimals is a little bit more difficult than what we're about to do. It's much easier to convert decimals into fractions. All that we have to do is identify the placement of the last number in the decimal. So what do I mean by placement? Well, you've probably heard of thousands before, or hundreds, or tenths, or millions, or millionths. All of those are places in larger numbers. So the 8, that is the first number to the right of the decimal, is actually in the tenths position. The 3 is in the hundredths position. Now, which one is more important to us here? The 8 or the 3? It's the 3. We're always looking for the number furthest to the right. And since that 3 is in the hundredths position, we know that we can take that 8-3 and just place it over the number 100. And just like that, we've converted this decimal into a fraction. The only complication that you'll sometimes get, often get actually, is that sometimes these fractions, you're able to reduce them. In this case, we can't reduce 83 over 100, but what if we had the fraction 28, let's say we had 0.28, and we went, oh, well, that's pretty easy. We know that that's 28 over 100 because that 8 is in the hundredths place. All right, pretty simple. But usually your teacher's not going to want you to stop there. Once you get a fraction, you're usually obligated to simplify or reduce it. How do we do that? Well, we want to think of the largest number that goes into both the numerator in the top and the denominator in the bottom. Now, if you can't think of the largest one, then just go with anything you can think of. Clearly, a 2 will go into both because both 28 and 100 are even numbers. But if you can think of a larger number, go with that one instead. So right away, I know that 28 is divisible by both 4 and 7. Well, 7 doesn't go into 100, but 4 does. So I'm going to say we can reduce both 28 and 100 by the number 4. And how are we going to do that? Well, let's think. How many times does 4 go into 28? Goes in 7 times. How many times does 4 go into 100? Goes in 25 times. So just like that, we were able to reduce the number 28 over 100 to the fraction 7 over 25. All right, that's our lesson for today. I'd like to continue a little bit with this next time and take it a little further. My name is Adam Reich. Thanks for watching WonderfulTutor.com. If you have any questions, please feel free to send them my way. Visit my website, get in touch. See you on the next